right, so what more can we do? Let's add a few more pieces to the puzzle here. Let's actually interact with the cat now. Let me go ahead and now, when the green flag is clicked, let me go ahead and ask a question using an event here. Let me go ahead and say if, let's see, if the cursor, I want to do something like implement the notion of petting the cat. So if the cursor is touching the cat, like here, something like this, it'd be cute if like the cat meows, like you're petting a cat. So I'm going to ask the question when the green flag is clicked, if, let's see, I think I need sensing. So if touching mouse pointer, this is way too big, but again, the shape is fine. So there it goes, grew to fill. And then if it's touching the mouse pointer, that is, if the cat to whom this script or this program, anytime I attach puzzle pieces, MIT calls them a script or like a program, if you will. Let me go ahead then and choose a sound and say play sound meow until done. All right, so here it is to be clear. When the green flag is clicked, ask the question, if the cat is touching the mouse pointer, then play sound meow. Here we go. Play. Huh. All right, let's try again. Play. Huh. I'm worried it's not Scratch's fault. Feels like mine. What's the bug here? Why doesn't this work? Yeah, and back? Yeah, who just turned? Yeah, the problem is the moment I click that green flag, Scratch asks the question, is the cat touching the mouse pointer? And obviously it's not, because the cursor was like up there a moment ago, and it's not down there. It's fine if I move the cursor down there, but too late. The program already asked the question. The answer was no, or false, or 0, however you want to think about it. So no sound was played. So what might the solution here be? I could move my cursor quickly, but that feels like never going to work out right. Other solutions here? Yeah, and way back? The forever loop. So I could indeed use this forever loop, because if I want my program to just constantly listen to me, well, let's literally do something forever, or at least forever as long as the program is running until I explicitly hit stop. So let me grab that. Let me go to Control. Let me grab the forever block. Let me move the if inside of this forever block, reconnect this, go back up here, click the green flag. And now, nothing's happened yet, but let me try moving my cursor now. So now, that's kind of cute. So now the cat is actually responding, and it's going to keep doing this again and again. And so now we have this idea of taking these different ideas, these different puzzle pieces, assembling them into something more complicated. And I could definitely put a name to this. I could create a custom block. But for now, let's just consider what kind of more interactivity we can do. Let me go ahead and do this by, again, grabbing a when green flag clicked. Let me go ahead and click the video sensing. And I'm going to rotate the laptop, because otherwise we're going to get a little inception thing here where the camera is picking up the camera is up there. So I'm going to go reveal to you what's inside the lectern here while we rotate this. And now that we have a non-video backdrop, I'm going to say this. Instead of the green flag clicked, actually, I'm going to say when the video motion is greater than some arbitrary measurement of motion, I'm going to go ahead and play sound meow until done. And then I'm going to get out of the way. So here's the cat, and we'll put him on top of there. Just OK. All right, and here we go. So my hand is moving faster than 50 something or other, whatever the unit of measure is. And thank you. So now we have an even more interactive version. But I think if I sort of slowly, right, it's completely creepy, but I'm not like exceeding the threshold until finally my hand moves as fast as that. Here, the goal was to demonstrate that by using some fairly simple primitives, some basic building blocks, but assembling them in a fun way with some music, maybe some new costumes or artwork, you can really bring programs to life. But at the end of the day, the only puzzle pieces really involved were ones like the ones I just dragged and dropped, and a few more, because there were clearly lots of moles. So the student probably created a few different sprites, not a single cat, but at least 4 different moles. They had like some kind of graphic on the screen that showed Sahar where to position her head. There was some kind of timer, maybe a variable that every second was counting down. So you can imagine taking what looks like a pretty impressive project at first glance, and perhaps overwhelming to solve yourself, but just think about what are the basic building blocks and pluck off one piece of the puzzle, so to speak, at a time. And so indeed, if we rewind a little bit, let me go ahead here and introduce a program that I myself made back in graduate school when Scratch was first being developed by MIT. Let me go ahead and open here. Give me just 1 second. Something that I called back in the day Oscar time that looks a little something like this. If I full screen it and hit play. So you'll notice a piece of trash is falling. I can click on it and drag. And as I get close and close to the trash can, notice it wants to go in, it seems. And if I let go, 1 point. Here comes another. I'll do the same, 2 points. There's a sneaker falling from the sky, so another sprite of some sort. I can also get just a little lazy and just let them fall into the trash themselves if I want to. So you can see it doesn't have to do with my mouse cursor. It has to do apparently with the distance here. Let's listen a little further. I think there's some additional trash is about to make its appearance. Presumably there's some kind of like variable that's keeping track of this score. OK, let's see what the last chorus here is. OK, and thus it continues. And the song actually goes on and on and on. And I do not have fond memories of implementing this and hearing this song for like 10 straight hours. But it's a good example to just consider, how was this program composed? How did I go about implementing it the first time around? And let me go ahead and open up some programs now that I wrote in advance, just so that we could see how these things are assembled. Honestly, the first thing I probably did was probably to do something a little like this. Here is just a version of the program where I set out to solve just one problem first of planting a lamppost in the program. Right? I kind of had a vision of what I wanted. You know, it evolved over time, certainly. But I knew I wanted trash to fall. I wanted a cute little Oscar the Grouch to pop out of the trash can and some other stuff. But wow, that's a lot to just tackle all at once. I'm going to start easy, download a picture of a lamppost, and then drag and drop it into the stage as a costume. And boom, that's version 1. It doesn't functionally do anything. I mean, literally, that's the code that I wrote to do this. All I did was use like the backdrops feature and drag and drop and move things around. But it got me to version 1 of my program. Then what might version 2 be? Well, I considered what piece of functionality, frankly, might be the easiest to pluck off next. And the trash can. That seems like a pretty core piece of functionality. It just needs to sit there most of the time. So the next thing I probably did was to open up, for instance, the trash can version here that looks a little something now like this. So this time I'll show you what's inside here. There is some code, but not much. Notice at bottom right, I changed the default cat to a picture of a trash can instead, but it's the same principle that I can control. And then over here, I added this code. When the green flag is clicked, switch the costume to something I arbitrarily called Oscar 1. So I found a couple of different pictures of a trash can, one that looks closed, one that looks partly open, and eventually one that has Oscar coming out. And I just gave them different names. So I said switch to Oscar 1, which is the closed one by default. Then forever do the following. If touching the mouse pointer, then switch the costume to Oscar 2, else switch to Oscar 1. That is to say, I just wanted to implement this idea of like the can opening and closing. Even if it's not exactly what I wanted ultimately, I just wanted to make some forward progress. So here, when I run this program, by clicking play, notice what happens. Nothing yet, but if I get closer to the trash can, it indeed pops open, because it's forever listening for whether the sprite, the trash can in this case, is touching the mouse pointer. And that's it. That was version 2, if you will. And if I went in now and added the lamppost and composed the program together, now we're starting to make progress. Right? Now it would look a little something more like the program I intended ultimately to create. What piece did I probably bite off after that? Well, I think what I did is I probably decided, let me implement one of the pieces of trash, not the shoe and the newspaper all at once. Let's just get one piece of trash working correctly first. And so let me go ahead and open this one. And again, all of these examples will be available on the course's website, so you can see all of these examples too. It's not terribly long. I just implemented in advance so we could flip through kind of quickly. Here's what I did here. On the right-hand side, I turned my sprite into a piece of trash this time, instead of a cat, instead of a trash can. And I also created, with Carter's help, a second sprite this one a floor. It's literally just a black line, because I just wanted initially to have some notion of a floor so I could detect if the trash is touching the floor. Now, without seeing the code yet, just hearing that description, why might I have wanted this second sprite and this black line for a floor with the trash intending to fall from the sky? What might I have been thinking? Like, what problem might I be trying to solve? Yeah? Yeah, you don't want the first sprite to start at the top, go through, and then boom, like you completely lose it. Like that would not be a very useful thing, or it would seem to maybe eat up more and more of the computer's memory if the trash is just endlessly falling and I can't grab it. It might be a little traumatic if you try to get it and you can't pull it back out and you can't fix the program. And so I just wanted the thing to stop. So how might I have implemented this? Let's look at the code at left. Here I have a bit of randomness, like I proposed earlier, exists. There's this blue function called goToX, y that lets me move a sprite to any position, up, down, left, right. I picked a random x location, either here or over here, negative 240 to positive 240, and then a y value of 180, which is the top. And this just makes the game more interesting. It's kind of lame pretty quickly if the trash always falls from the same spot. Here's just a little bit of randomness, like most any game would have, that spices things up. And so now if I click the green flag, you'll see that it just falls. Nothing interesting is going to happen, but it does stop when it touches the black line, because notice what we did here. I'm forever asking the question, if the distance of the sprite, the trash, is to the floor is greater than 0, that's fine. Change the y location to by -3. So move it down 3 pixels, until the distance to the floor is not greater than 0. It is 0 or even negative, at which point it should just stop moving altogether. There's other ways we could have implemented this, but this felt like a nice, clean way that logically just made it make sense. And OK, now I got some trash falling. I got a trash can that opens and closes. I have a lamp post. Now I'm, a good 3 steps into the program. We're making progress.